Let's record. Yes. So I've it's recording. Okay. Yeah. So we can be. Is there somebody else joining?
Maybe they'll just later. Let's just proceed.
Yes.
Yeah, we just move on.
Okay. Let's proceed. So okay. So it's we're looking into Scratch. I hope you're able to see my screen. Are you seeing what I'm sharing?
Yeah, I see your screen.
Yeah, seeing my screen. Thank you. So Scratch. This is the basic interface. Have you used it? Do you usually use it to teach the kids so that I know where to begin?
Yeah, on my side,
Yes.
I use it to the kids.
Oh, you use it to teach the kids.
Yes.
Okay, so I can just go over the basics very quickly and then we go to the main thing because for today I was targeting, we see how to make a simple game. This is a very simple game. Any child from grade 3 to grade 4 should be able to do this in about 1 or 2 lessons, 40 to 80 minutes. They should be able to understand the concept and then execute and do, as long as they've been introduced to the basics of Scratch. So this is the Scratch interface. These are the tabs. This is the code tab. This is the background tab. This is the sound tab. I love this. Here up here is the main menu. The menu tab, yeah, you can call it the menu tab or the main menu. And then here we have the blocks. Okay, and here we have the category of the blocks. And then down here, we have what you call extensions. This where if you want to do the really advanced and the interesting things, extensions. So if you see in any programming language, not just Scratch, if you want to do something extra, you add what is known as extensions. Even if you want to do it in, if you want to go to Google Chrome and you want to do something special in Google Chrome, like maybe take a screenshot of your web page, you can add an extension. So extensions are just basically things you usually add to your program to give it more functionality. So if we click on the extension here, we'll see there are a few extensions. Like music, if you want to, you can even create for music. I think music right now is very prominent because in the current syllabus, ICT is integrated in all other lessons, such that if you want to, there's a way you can teach Scratch using music. So if you want to do a music code, you can come here with a pen, drawing, like for that day when you are drawing polygons. That one we'll look at in a few other lessons. We'll look at how to draw polygons. And then video sensing. In a lesson or two, we'll look at a game which can do video sensing. As long as the computer or laptop or even the phone which you're using has a web camera, you can create a game whereby the person in real life is interacting. Like we can have a game where balloons are falling down, and then once the balloons fall down, when somebody touches a balloon which is falling, the game it will pop in the game. So somebody is doing actions in the real life, and then those actions are captured in the game. So video sensing we can create some very interesting games where the person where the user can interact ako hapa real life, lakini ana interact na game using actions of the video. So text to speech, you will also explore all this. And down here, there are some coding, like for example, microbit. Even though while I'm teaching, I don't usually use for Scratch. I usually use for make code. I'll show which one it is. But since it's a holiday and it's time for learning, I can even look into how we can use the microbit. So we have a few microbits in our lab. I'll show you how they look like. And then Lego, these are different types of robots. So if you want to do robotics, you can use even Scratch. But now you have to make sure you buy the robots from the company called Legos. So Lego is a USA company. So when you buy the Legos or you go to an organization which has the Lego robots, we can program those robots using Scratch. Even though as we have some robots, yes, but them they use TinyBit. So there is a company of China. So we have to use make code. We can't use Lego. We can't use Scratch. Later on, I'll show you examples. But now, if you purchase robots of these ones, you can use Scratch to code those Legos. But either way, whichever program you use, all of them are called block-based because let me press back to go back to the main page. Because this when you're programming, we program using, let me click sprites. We program using blocks. These ones are the blocks. So we program using the blocks. So yes, so the robots are block based. So even if it is Scratch or make code, once you know how to use Scratch, make code becomes very easy. It's just application.
Okay, you can just go back to extension.
Extension, yes.
So that I can be able to ask their question.
Okay.
So under Lego.
Yes.
So is there that in Kenya? Do you have those robotic?
Yes,
they're there.
They're there. There's a company. There are people who do know when they noticed the Kenyans are introducing robotics. Some companies bought Legos, and then now they go from school to school because many schools don't know how. If we buy, what do we do? If we they don't know the entire process because they don't know how to code, how to buy, how to all those things. So a company will come. They say we are going to bring the robots. We are going to teach the children for you. Obviously, they are making money, but now in my case, we saw that they usually charge maybe a lot of money, and it is easier if you buy the robots. You have them, you train yourself, and then we train the student. That way, even you can teach students for 10 hours. But if these people come, they teach for 1 hour, 2 hour a week, and they charge a lot. But those companies are there, and if you can talk to them, we can convince them they can sell. They usually import. Like even us, we imported from China, and Kenya KRA, how corrupt it is. It was held in the air. It was held in their. They got down because they said that the evaluation was not done properly. It was held for 3 months. We had to add another 40,000. It's a process, yes, but once you have the robots, now hakuna stress. We just teach. So we are able, even if it is in America, you can just pay with you put money in the bank, you put on the card, you pay online, they ship to you, and then they bring. So people usually do those processes for other people because hey, these steps mingi. So they are there. Even if I talk to one of these companies, I have a few contacts, them they can resell, or if you want to, you can buy from the source, and then we use. So the school is to weigh. Is it easier? We just tell these people to bring them, but when they bring the robots, you find that they charge per student per term. You can charge maybe 5,000, 10,000, a lot of money, and then the school gets some bit. So it can be expensive, or you can decide to train, and then you do yourself. So you'll struggle getting. Once you buy them, it's easy. You're free. You can code anytime. You can set your timetable. You can do anything. Yeah, that's what I think. So you can
okay, that's fine. So we can move on now.
Yes. So acquisition, that one I'll look at how to buy. I'll talk to 1 or 2 people to see if they're local resellers or you have to depend on importing. Anyway, this is the main coding. So here is the stage. Here's the stage, and then here is for setting the size. If you want it to be small, or if you want it to be big, you can change. If you want it to be a bit big, to reduce the sprite area, or you can change that one. Or if you want the coding to be full screen, you can come here to set the stage size. Sprites, you can choose sprites from here and here. Okay, sprites you choose here, and then the backdrop, the background you choose from here. So for today's game, you wanted a simple game, an animal that is chasing something that it wants. And now, in the case of what I do, I was saying the game is like this. There's a cat which is chasing some food.
Okay, Solomon, just a minute.
Yes.
Do you see my arrow?
Arrow. No, not.
Oh,
Oh, you're controlling. Oh, let me stop. Yes.
so
Boom,
I
move
wanted.
it.
Do you see it? I
No.
wanted you to explain on me on these ones.
Okay. Let me minimize. Yes, so that I see the full page. Yes. But now move the arrow. I see.
Do you see?
Oh, where's the mouse pointer? Which area are you? Let me move it again.
Okay, move your arrow. I see.
I've removed it. Are you seeing my arrow? Move, yes.
I see your arrow. So just bring it. It is beside the sprite.
Here?
Up there, where they have written name, sprite, show.
Oh, these ones? These ones?
These ones.
Okay.
Yes.
So if you are a sprite name, okay, so let me take, for example, the game is the cat is chasing up food. So we are supposed to make sure the cat does not eat the food. So that is the game. You are trying to avoid to make sure the cat is not eating the food. So let's say the cat is flying. So when you here, this one now is the sprite name. You can call it cat flying, or if you have any other name, even you can put the name, your own name. If it's a student, you can put the name of the student. For example, we will do another example where a cartoon where there are two people talking. So if you want the sprite name, so that it is easy, if you have maybe 3 or 4 sprites and you want to know who is talking, it will be easier. Once you give the name of the sprite here, so this one is called cat flying. So when you're coming here to code, like for example, you want to code something, we point towards what? And like if you want now, let me add another thing so that we see properly. Let me add a food, like let me go to food, and then I go to maybe this donut. So if I come here to when I'm coding, do you see these blocks? Are you seeing the blocks? So if I want to choose.
Yeah, I see. Look, how are we? I wish you could also change the backdrop.
Oh, let me change the backdrop so that, yes, so that it is clear, yes?
Yes.
That one is clear now. So the purpose of the name is, if now when you're, right now I've chosen the donut. So if I'm coding donut and I want to interact with the cat flying, this I'm able to now choose. I'm able to know, yes, now as I'm coding this one, I want the cat which is flying to do something. So that the name, or if I choose the cat flying, if I want to code the donut, I'm able to code the donut. So that is the purpose of the name. So that as we are doing the coding, we know what are we referring to. Yeah. So we know what we are referring to. So that is the purpose of the name. And then this one is the X axis, and then the Y axis. Okay. Axis. Yes. So if I move the cat, you see the coordinates are changing. If I move towards this side, X is increasing. You see? If I go upwards, Y is, sorry, somebody is calling and internet is on my phone. Let me just speak quickly. Sorry.
Okay.
Hello. Nzuri sana.
Yes, napigia kutoka Stadium naitwa Eric.
Star? Okay, sorry. I'm in the middle of an online class. Kindly call past 5 o'clock.
Okay.
Thank you very much. Or I'll call you back. You have a good day too. Sorry for that. Unanisikia?
Ninakupata.
Okay. So yeah, so X coordinate means each point in this screen, let's imagine an imaginary line. There is plus EV. So unakumbuka mathematics, Cartesian. Is it form 2? Then I've not taught maths. I've been teaching computer so much. So ile Cartesian plane, which is like this, it's like a plus, like this. So at the center is 0, 0. So the more you go this side, the more x increases. The more you go upwards, the more x also increases. When you go downwards, x decreases. So if it is below 0, x will be, oh no, y will be negative, it is downwards. If it is on this left side, if you go this side, you find x will be negative because it is, the more you go this side, the more x becomes negative. The more you go down this side, the more y becomes negative. So each point on the screen has a coordinate. And once you know how to use the coordinates, I hope I'll have time to do an example. You can tell this thing to go to one exact place as long as you give it the x and y coordinates. So these are just the coordinates telling where the object is, and you can code them. Do you see these ones? Just the way it is here. For example, if you go to glide to, you can tell it, I want it to go, like for example, this donut is here. And then now I want it to go to the very center of the screen. So I tell it glide to 0, 0. So when I click, it has come to the center of the screen where the coordinates are 0.
On that, so on that one, you have gone to the code motion, okay?
Yes, code motion called glide. Glide is like
glide.
sliding. Yes. So this
sliding.
So if you increase this time for sliding, it will slide slowly, okay? So if I take it again far, and then now instead of 1 second, I've said 2 seconds. So if I press it, it is taking 2 seconds to come to that place where you have told it to come, to the 0, 0. So if you want it to go quickly, you reduce to less than 1, 0.3. So let me move it back, and then I press, it will come very quickly. So gliding time is the time it takes to move as you're saying it. But if you're telling it to go to, this go to also has x and y. So that go to means it will just jump. It will go there, even you won't see it moving. That's the difference between glide and go to. Go to, it will instantaneous. The gliding time is 0, it's not there. But glide, you'll see it sliding. So if you tell it 10 seconds, it will go very slowly. It will take 10 seconds to go there. So these coordinates just show where the sprite is on the screen. And but if you want now to program, if you want the sprite to do something on the screen, you can use the same numbers, the same coordinates to tell it to go to this place or that place.
That place.
So like now, for example, the other thing is, this one is show or hide. If you want the sprite to be invisible, you can tell it show or you can hide it. But this one is now coding. This one is while the program, you're still designing the program. If you want to hide it, you hide it. If you want to show it, you show it. But you can also do the same by giving it an instruction here. Under looks, you can tell it hide. There should be hide somewhere. So this one, there's hide and there's show. So this one you can give the instruction here. Instead of now just using this interface here, you can tell it show or hide or show. So depending on what you are coding, and make sure you check what is being coded. So because sometimes a common mistake is somebody will be, you want to hide the cat, kumbe the donut has been selected. So you'll see. So that's usually a common error. And then size, like for example, I'm thinking this donut is a bit big compared to the cat, okay? So I want to reduce the size in terms of percentage. So this is 100%. If you go more than 100%, let us say 150%, it will, sorry, I've made that mistake. Diane, I've just said, I've coded the wrong thing. Let me return it to 100. I want to change the size of the donut. So I choose the donut. And then if I want now to increase the size, I come here, say 150%. So you see it is large. But if I want now to decrease it, because now for it to make sense, it has to be smaller than the cat. That's a reasonable size. That is 50% of the original. If it is too small, you just add a bit to 60%. So that one is for the setting the size of the sprites, this size. Then direction is the side in the direction in which it is pointing. So if I click on the direction, do you see now it's pointing? This one is pointing along the x-axis. So if I increase the degrees, it can change the direction in which it is facing.
Yes.
So sometimes maybe the sprite is facing this side and you want it to face the other side, you can
The other
do
side.
you can change here. So you can use this dial. If you want it if you don't want to use the numbers alone, you click on the word direction, and then this clock-like thing will come, and then it will now. So if you want it to be exact, I just wanted to space 90 degrees. There it was. It will. So you can set by writing the number or by clicking and then allowing this clock thing to set the direction. So yeah, a backdrop, I'm sure, just if you want the category you want, you just choose, then you pick the one which you want. Then
so this background goes with the story you want to create.
Yeah, story, because I'm thinking, because now it's clear. It's clear. So I want to make a story where the cat is chasing the donut. So if it has many things, if it's a game, the background should be a bit clear so that we are able to see here. But if it is like a story, like a cartoon, you can have a background with many things. If it's like a cartoon, you can put those ones. But if it's a game, I usually think this one is nice because now the person can now focus on these two things. So in this game, if you want the purpose is to make sure as the cat is flying on its own, okay? And then the game user, it should be able to now move this donut so that the cat does not eat. So this cat wants to eat this donut, and you want to protect the donut from being eaten by the cat. So in this game, what is being controlled is the donut. You want to move the donut up, down, left, and right. So let's use arrow keys. Okay, so first I choose the donut, and then I go to control. When I go to control, not control, events, sorry. Under events, so instead of flag clicked, we want now to use the keyboard. So when space is key pressed. Now when I press here, you'll notice most keys on the keyboard, up, down, left, right, any key, A, B, C, D, up to Z, all the alphabet keys are here, all the numeric keys are here. So you can use anything, alphabet, numeric, or arrow keys to control this one. So when space pressed, space is just the default, the automatic setting. But now you can use any. So I want to use up, down, left, and right. When up arrow is pressed, I want it to go up.
Try to zoom the code.
Oh, I zoom the code, okay.
Yeah.
Yes. So inaonekana sasa. Okay. When up arrow is pressed, then we go to motion. So when up arrow is pressed, we change X by, you can say 20. So these values are just experimental. Just choose a value. If it's not working, you can increase or decrease. So change X by 20. So when I such that when on my keyboard, I'm pressing the up arrow. No, that's sorry. Change Y. Change Y by 20. Because up and down is Y axis. Sindio? And then left and right are X axis. X axis, yes. So that's really another common place where Nashida, up and down is Y, X. So up is positive, down is negative. So up is change Y by 20. So that when I press up, it is so up arrow. When up arrow is pressed, this is going up. Sindio?
Yes.
Yeah.
Yes.
So we are not able to make it go down. So how do we do that? We can take the space, and then instead of up, we say you want it to go down. Sindio? When down arrow is pressed, it's still the Y axis, but now it is negative. Downward is negative. When they change Y by negative 20. So even this one is good, even because grade 8 are doing even the Cartesian plane, Sindio, in mathematics.
Yeah.
So this can be an interesting way for them to explore X and Y. But for the younger ones, We can just, because them, they don't have the understanding, we can just tell them, put this value there, put that value there. But for the real understanding now application, grade 8 ndo naweza. Though the younger ones, if you just show them this, they're able to repeat the steps. Up and down. Oh, running out of time. And then the next is X axis. Hey, they're saying 9 minutes. I thought it was 1 hour. Hey, these people. Yeah, wanasema 9 minutes.
Maybe wamekupatia duration of 40. Nenda na 40.
Hiyo ni 40 minutes.
Yeah, you say after 40.
What's 1 hour?
After see 1 hour after 40 when you go for after 40 after going for 10 minutes. Then you can come back again.
Oh, can I use the same link or another link?
You just use the same link.
Oh, so we can, after 10 minutes, it will just continue. Okay. So tuendelee tu. Nimezoea ninio inaitwa ya Google. You want 1 hour. Anyway, so and then I take when space, and then I left. Left is X negative. Change X by negative 20, and then up, down, left, and then the other one is right. Still, when space is key pressed. So when space is key pressed, and then I change the key which I want to use, which is the right arrow key. And then now I go to motion, and then I say change X by positive 20 because I'm going to the right. So once I come here, I press on the stage, I'm able to go downwards, I'm able to go left, I'm able to go right, and I'm able to go up, down, left, right. So we have set. So now we are able to move. And if you can even press 2 at the same time to go diagonal. If I go press up and right, it will go diagonal. Yeah. So now,
on that one, you just use 1 button.
Yes, you can use 1 button, or you can use 2. If you use 2, it goes diagonal. But the objective of the game is to make sure that as the cat is coming towards the donut, you are escaping. You're escaping. You don't want the cat to eat it. So let's make this cat to chase this donut. So we go to the cat. So so you want the cat. So the triggering event when the game starts, when we click the flag, we want the cat to fly towards this one. Okay. So we go to motion, and then we say point towards donut. That's why it's good to know the name. So the name is donut. So it will point towards the donut, and then we want it to move 10 steps. So let's try. If I press the flag. Okay. So this now it's moving, but it's moving 10 steps. But now we want it to move it continuously. Cindy? So what do? We make it loop to repeat. No, you repeat on its own so that I don't have to press this one for it to do. So we make it to repeat, and that's under control. We can say forever. So forever, and then, so when I press it like that, it is flying towards the donut. So when it reaches there, so I'm trying to escape. It's moving so fast. So I can reduce the speed. If it is too fast, let me stop the game. If it is too fast, I can make it a bit slow. So I can say move maybe 4 steps. And then I put it here, and then I put it here so that as you're starting the game, it is easy, and then it becomes hard. So when I press flag, this now it's flying. Then you're supposed to make sure the donut is away from there. So this game is not yet perfect, because now yes, it is working. At least the basic mechanic is working. You can move around, try to escape, and then the cat is chasing the donut. But now, yes. So the only problem is once the cat reaches the donut, the game is supposed to stop.
To end.
To end. Or you can, instead of even saying to end, let's first say, let's start with for it to end, and then we'll add something. Hapo mbeleni tutaongeza kitu. The game is supposed to, like, for example, we can say 50 points. If it hits 49 points, or 10 points, if it hits 9, when it reaches 0 points, the game ends. Or let's start since in step by step. So the next step is when the cat eats the donut, what we can tell it to start again. Cat yende huku, donut yende huku. As soon as it touches the donut.
Maybe that's for the point. It can be a good one.
Oh yes, so that when it touches in another 10,
yeah.
So let's code like that. So we go to sensing, such that if the cat is flying, sindio, we under cat. If the cat is touching the donut, what should it do? So this is the shape of this one. It's like is it a diamond? That means it must be used with if then. Smona if then they can shape. So it can be used with if then, wait until, or repeat until. So those are the loops which can be used with this sensing. As it tumika na hizi zingine. Can be used with if then, else. So we can, let's start with if then. If it is touching, if it is touching the donut, then what do? We say we tell the cat to go to, if it is touching the donut, we can tell the cat to go to this point. So if these numbers are confusing, I can tell you to go up here. And if I don't know which coordinates are here, I can just move it to the mouse, and then it will set for me the numbers. You may set number because you may not know this corner, which numbers are there.
Try, see.
So I've set, I've told it it will go there, and then it will go there, and I want it to face, point in direction 90, so that let me point it manually. Yes, so that it is, even if it was facing which direction, it will start again. It's like it is starting again. So it will face that side like that. And then it will go here. So if touching the donut like that, it will do like that. So let's try. Now, before that, we have to set the beginning when flag clicked. So when flag clicked, this thing will be activated. So it will not do anything until it is touched by the donuts. So let's try and see what happens. So we are supposed to activate. Yeah, because if touching, let's check what if touching donut, go to X pointing direction. And if I click like this, so this event which is triggering the event which is triggering it is not working. So we can let's use another one. We can use broadcast. Which the right trigger? I'm thinking if I call. Let's put all of them under the same one and see what happens. Yeah, so it should be under the same. Sorry, so it should be under the same. Coding one even you try another. So that one is working. So you're avoiding. If it is touching, it goes to the beginning point to allow the person to maybe play. So evil. So the game is now to try to avoid the cat touching the donut. If it is a bit hard, maybe you can make the cat move slowly, and then you can make the donut move quickly. So if you want the donut to move quickly, you can say change by 30, so that it's able to move.
Philemon.
Yes.
Philemon.
Yes.
You can just take a break of 10 minutes.
10 minutes, okay.
Then we come and finalize.
So do I need to do anything on my side, or you just click and it will continue?
Or you see like it has less than 1 minute.
1 minute,
to
yes.
go.
Yes.
It's just going to give us automatic. Just going